Hey guys, I have another video that I wanted to show you. I wanted to work more on that reoccurring pattern that I was working with in the last video, which is this right here. It's kind of shaped like a hockey stick, I guess, or something, but it's actually an image of rotation, and you can just look at it and know that this is from rotation. This is spinning, and you can see what it's doing. But for some reason in plate tectonics they don't see it that way. Instead they see this as a subduction zone. What they think is happening is that they think this plate here is sliding under this. Okay, I've been told that I don't know anything about plate tectonics, so just bear with me. But you can see that there's more than that going on. There's what they think is a plate sliding underneath another plate, which seems to be leaving no debris whatsoever. I mean, you know how heavy these things are, and you realize how much weight that if they were sliding underneath each other, how much of the top soil would be scraped off into a pile. You don't see that there. Instead, you see a nice, crisp, clean, what do you want, a crease. Okay, and what I'm claiming is that what's happening is you're seeing a flattened image of something that used to be, well, three-dimensional. It used to be open here, and this used to swing around. And that's what I believe this is going on here. And what they think is a subduction zone may be just cooling after a cataclysm, you know, as things shrink. And you know, it's funny, I was thinking about this, that the ocean levels would also rise if the planet was to shrink down a little. And like the magnetic fields of our planet, I'm sure that this planet expands and contracts. But a contraction and an expansion could take probably decades. It could take a long time. But in that long time, you know, plate tectonics arrives, and we've got people that are looking at what they think is subduction, but it's actually just retraction. But it's not going to always be like that. So it's not scientific to assume that things are the way they seem at the moment, that they'll always be like that. It's just, that's not scientific at all. That's bias. So anyways, I wanted to show you the things that plate tectonics won't be able to account for, and that's these alignments. And that's just the way it is. I mean, it doesn't matter how many trolls get upset over what I say, like, you know, when I say something like that. It's just, I'm trying to be honest, is all. I get people so angry at me when I make claims like that, but you know, I only make them because I believe they're true. And just look at the alignments to see it, you know. I mean, come on. There's people that look at these and go, they don't align. There actually are people that do that. They look at this and they think, nope, that doesn't align, but it does align, you know. It gets me pissed off too a little bit. It's like forcing themselves not to see it, you know. But anyways, I don't want to talk through this whole thing. I just want to show you the alignments. You got, even here is an alignment, and you know, if this fits here, well, it has to fit here. You know, this has to fit there also, because that would, you know, support what I'm saying. If they didn't fit, then we might have a problem. Okay, so let me get this straightened out so we can. Okay, this fit here, and it fit here. Therefore, this must fit here too. Or I'm wrong, right? But if it fits there, it supports what I'm claiming. So we put that there, and then you can see what happens with the rest of the stuff here. You can see that that's starting to fit into there. You can see that this and this fit in there, and this fits with this. You can see it lines up with stuff in the background on the surface of Australia. But you got that like that. You look at this stuff right here, and you look at this behind it, and then you look at it again when you line it up, and you can tell that this is moving through. But on top of that, before it even gets there, you got this. Let me back out. And you got this stuff here to think about too, and look at when you bring this right here. How is this possible if there's plates underneath here? Did the plates, where's the plate now though when I put this on here? See how it fits right there? You got this swirling thing here. Okay, so I'm just trying to, because this will do this all over the place, because the whole thing, everything on this planet came from a small area, so things are going to fit over and over and over again, because that's what you'd expect it to do. See how you got this all thrashed up right here? It looks like it's been chewed apart by piranhas or something, or wild Seahawks, I think, would do that. You know, like if they had rabies or something. Seahawks, man, those things are dangerous. Anyways, see how it fits in here? See how this is, the lines and everything are just chewing it up? You can see that this is all related. See, look at the lines just slicing through, wreaking havoc. Look at that. The Seahawks are just going crazy. What is a Seahawk anyways? Isn't that like a seagull or something? See, look at the peninsula here. And then you got the top to contend with here. And you got these right here inside here. This is what I'm showing you, and I showed you this right now. And then while that's lining up there, you got to look at this too. This fits right in our little star right here thing, because it's a point of rotation. Things seem to happen in the point of rotations. I'd guess that mineral deposits would be there, and all kinds of strange land features from rotation. And then don't forget behind it, see how that fits in there? This hits a peak right here. God, it's hard to keep the center when I do this. And then what the cause of all these marks? Here we go. Well, there's another cause though, but that lines up with this. But you can see this is one of the culprits here. look at rotation, and it would line right in. See how it's all related? Okay, that's just that. And if I run this up here, you get a whole nother story. But so let's get that out of the way. We're done. Well, we're not done with that actually, because well, check this out. Here's one. Here's Alaska. Who would ever thought that Alaska would be related to this too? But it is. See, as I bring it in, this thing's like busting right out. And then you got alignments right here. But not just there, but also here. You can tell this is swirling around. And see how it fits around? Right there, and that. Let me back out. This is not known in geology. In plate tectonics, this is impossible. This is swirling. And where's the plates? In the Mid-Atlantic Ridge. See, the Mid-Atlantic Ridge is right here. But I'm not ready to show you that yet. But you see, okay, so this goes on and on, by the way. I can line this up here, and it's just going to continue to fit over and over again, because they're all related to the process that created them. Now this too even, but you got to look at it in the right way. The Himalaya Mountains is supposedly a collision, but yet every single peak matches with every single feature under here. When I line it up, every single one. Now this looks more arched than this, but that's because it actually goes through it a little bit like this. And then you see the ends here. Okay, so, and then you got that big giant crater that some people call a bluff or whatever, like it's like insignificant, but that's a huge crater. Originally, when I first saw this, I thought it was from a meteor that came in at an angle, like it ricocheted off the planet. But it's not a meteor impact at all. It's rotation, and this rotation kicks up this overspill. This rotation is the vortex. And this rotation is created by Birkeland currents. And those Birkeland currents can be seen right here in South America. And it's these mountains. These are the image of the Birkeland currents. And the reason why I say that is because if you look at the mountains, you can see that they wrap around one another. In plate tectonics, how could plate tectonics explain this mountain range going over this one and then wrapping around it and going underneath? It can't. No collision would do that, and no volcano would do that. And this is pretty huge, actually. It's a huge piece of land, and you can see that it's like a piece of filament or rope. Look how long that is, and it's still, the width is pretty much the same. And yet, like I said, you got pieces that are wrapping around. You even got pieces that have snapped off. They're snapped off and ripped, because this is, I believe this is the image of the North and the South Pole being created, because they're twisting and then they snap apart. And this is where the Earth is created, the core, everything. The core is the point where this split apart. That's what I think. I mean, from what I've seen, I can't measure the earthquake P waves, but I can just go by what I'm seeing here, and it makes sense. But yeah, this is what considering Birkeland currents, and you can see this rotation right here. This is it was a reversed S, and then somehow Google changed it to look like this. But I have the images of it. I have hundreds of them actually, and these are like two jumper cables right here. These are electrical, and it's obvious that they're filament, and they're wrapping around each other like they would, and then they short out. You can see the amount of energy that's been released by that just by looking at the land features. That's a lot of heat. A lot of heat and energy, especially right here. This is heat and energy, electricity. This isn't from a collision. This is from rotation. 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 You can see it in everything you look at. Everything is rotation, especially when they're round like that. When you have a round piece, that's rotation. This is rotation. This is a vortex. Here's the opening of it, and then all around it is creating stuff. This is the inner part of it, the very inner core of the vortex. And you can see the picture of something twisting down and snapping apart. Something broke. It's all in the surface features. Something broke and pulled away. But the amazing part is, though, when it broke and pulled away, this is it right here, and those filaments fit in there too, like a glove, which I'll show, I guess, maybe in another video, because I don't think I have time. But as it broke, you can see the stretching and the pulling away part broke. All of a sudden, all this matter came out and overfilled out of a vortex. This is usually 90 degrees the other way, but you got the top. This is all part of this is from the spinning. This is the Birkeland currents right here when they narrowed down, and a lot of energy was expelled, and then it just grew into a planet just like that. I mean, it's that easy to see. You can see the reoccurring patterns here. This is what's underneath here, and here you can see the same thing, the wrapping around, and then there's something pulling away. Like this looks like a fist almost, like, and you're looking at it, something snapping and pulling away, like a supernova in the electric universe theory. A supernova is when there's a break in the galactic currents, just like at one of those substations when they have those giant switches and they break apart and it throws a massive amount of electricity. That's what a supernova is, and this is how a planet is made, I think, like a miniature version of it. But that's what I'm seeing in here. So, and then the overspill. Now this is the second reoccurring patterns that I come across, and this is overspill, and you can find that everywhere. As a matter of fact, if I was to rotate this would look a lot like this. Shit. I just don't have time right now to do all that. Here, maybe I can do this one. Yeah, see if I can do this. Watch as I pull this in. You see the similarities, and then look at the overspill. This is like reversed of this. Yeah, watch as I line these up right here. You see the brothers here? It's the overspill. But yeah, here's another reoccurring pattern with the Himalayas. And here's another, here's the Himalayas. See how it lines up there, and then you got India lining up with this. And then this twisting into there. It's just, this one's complicated to see, and I don't have a whole lot of time to go through the whole thing. So, but see how the reoccurring patterns work over and over again? Because here's the Himalayas. Anyways, I'm kind of moving fast because I have to take my daughter somewhere. So. Anyways, let's see. Here's another recurring pattern with the Himalayas, and that's the Mid-Atlantic Ridge. Oh, shit. Yeah, here's the Mid-Atlantic Ridge right here. And here's the Himalayas. And they fit, when you really analyze this closely, it fits really well. And each line fits between the mountain peaks and everything. Because the Himalayas are related to, they're the reoccurring pattern for this part of the Mid-Atlantic Ridge, which they claim seafloor spreading is taking place, but there's more than that taking place.